Alright guys, so next we have already seen how to find a critical point, or basically stationary point is when dy over dx is equals to 0, or if you want to find your critical point, your dy over dx is equals to 0, and also your dy over dx is undefined. Okay, so we have critical value, critical numbers, and critical point. So now we are going to see how to how to find extremum point. So what is extremum point? Extremum point is basically maximum or minimum points. Okay, so maximum and minimum points. So the critical point that we have already find for this part, when we already do dy over dx is equals to 0, we are going to identify either the point is maximum or minimum. Okay, so there are two methods to find extremum point, which is by using first derivative and using second derivative. Okay, alright, so now let's see how to find extremum point by using first derivative test. So let's take a look first. Okay, so here we have there are two methods to determine whether stationary point is maximum or minimum point. Okay, maximum or minimum point, or sometimes the question will say extremum point, just the same thing, ataupun relative extremum pun benda yang sama juga. Okay, as you can see from here, we know that if we have a function like this is obviously maximum point, this is obviously minimum point. So let's take a look here. There are 3 steps. Okay, so ini saya tak nak baca lah panjang-panjang sangat, so kita simplifikan. So the first step is you have to find your first derivative. Nama pun first derivative test. So the first step is you have to find f prime x. Okay, first derivative. Your second step is you have to find your stationary point. So you have already learned in the previous video how to find your stationary point. Your dy over dx, your ataupun f prime x must be equals to 0. Okay, so that's it. The first thing is you have to find your f prime x, and the second step is your f prime x is equals to 0. So now when you find your f prime x equals to 0, ini the whole thing yang kita dah buat dalam previous video lah. You have to find your x, you have to find your y, and then you have to find the point lah. So the third step here, this is the new thing lah. So the third step is we are going to use first derivative test table. Okay, test table. Okay, so how are we going to use first derivative test table? Nanti kita akan tengok dulu. So before that, so as you can see from here, for first derivative test table kita, if our f prime x is less than 0, then f will be a relative maximum. If our f prime x is greater than 0, then our f will be relative minimum. Okay, if f prime x does not change, that means the function has no relative extremum. Okay, baca memang tak faham. Now kita tengok graph kita. Let's see. Here, obviously you know that this is maximum point. Okay, this is going to be your maximum point. Okay, so let's do this. This is going to be our maximum point. Let's say this is C. Okay, we know that this is our maximum point. So you know that here the highest value is f prime C is equals to 0. Okay, our first derivative is equals to 0. So that is how you want to find your maximum point. So as you can see from here, this is the gradient here of our f prime x, which is the gradient is greater than 0, positive. Okay, also this one here, the gradient is negative. F prime x is less than 0. Okay, so that is what this sentence means. If our f prime x positive and then our f prime x is negative, the point will be a relative maximum. Okay, relative maximum. Okay, the same thing work here. So this is let's say this is our C, and then here we have the gradient here. Gradient is f prime x, you know that. So f prime x here is less than 0. Dia akan turun ke sini. And here f prime x kita is greater than 0. So that's gonna be our relative minimum. Okay, what happened if your gradient is the same? So this here gradient and here is gradient as well. Okay, kamu anggap je lah dia macam kena. Okay, so let's see. Here kat sini dia naik, kat sini dia naik. That means this is positive, this is your gradient positive. If the gradient is positive and positive, that means the sign does not change. That means you have the point no relative extremum. Okay, maksudnya tak ada point lah. The point does not have maximum or minimum. Okay, same thing work here lah. Okay, confused sikit tapi tak apa. Let's just go to the example 3. Okay, this is we are going to use first derivative test. You know that your first derivative test we have to use a table. So find the stationary point of the curve and determine the maximum and minimum points. So as I said earlier, we have 3 steps. So the first step is we have to find the first derivative. Okay, this is very easy. So just differentiate. We should have 12x cubed minus 12x square minus 24x. Okay, jangan salah kat sini. Salah kat sini habislah semua salah. So let's see the second step here. Okay, first step. So the second step is to find our stationary point. So we know that to find stationary point is f prime x is equals to 0. So therefore we should have 12x cubed minus 12x square minus 24x is equals to 0. So remember, every time you have a equation like this, simplify first. So we can simplify 12, keluarkan 12x lah kita boleh keluarkan. So we will have x square minus x minus 2 equals to 0. So 12x equals to 0. Here we will have x equals to 0 lah. Tak apa, saya tulis lah. 12x equals to 0. And dalam ni kita boleh factorize kan. Which is we are going to get, sorry saya confuse sikit. 12x, so here we factorize, we are going to get x plus 1, x minus 2 equals to 0. So therefore we will have 12x equals to 0, x is equals to negative 1, x is equals to 2. So here is x equals to 0. Okay, so you have 3 stationary numbers. Ini saya tak nak tulis lah, confused. Okay, so we have 3 stationary numbers. So whenever you have your stationary numbers, mesti kena cari stationary value ataupun dalam kata lain value of y kita lah. So just substitute all these values into our original function. So we will have f0 equals to 5, f negative 1 equals to 3 negative 1, 4 minus 4 negative 1 cube, apa-apa-apalah. So here the answer is 0. So our f2, okay, substitute sendiri and you are going to get the answer negative 27. Okay, so now this is the last step. So the second step tadi to find stationary point. So last step, x3 is the table, first derivative test table. So bayangkan table ni macam kamu punya chapter 2, okay, our number line. So we actually have 0.05, negative 1, 0 to negative 27. So untuk table ni kita just focus on the value of our x, okay. So therefore here we are going to put our interval. Here we are going to put test value, and here we are going to put our sign f prime x, okay, and here we are going to put this as f prime x lah. Okay, so now, okay, number line. So the lowest value here is negative 1, so this will be negative 1, and then this will be 0, and this will be 2. Okay, ingat for table just focus on the x value. Okay, So here interval is negative infinity, negative 1, negative 1, 0, 0, 2, 2 to infinity. Okay. So test value, okay, boleh masukkan nilai test value kita. Here is negative 2, here is negative 0.5, 1, 3. Okay. So now, we are going to do, okay, sorry, the delay sekejap. What we are going to do next is, here we are going to sub our value of f prime x, okay, sign for f prime x. So we are going to take this value here and substitute into our f prime x. Okay, so negative 2 substitute into f prime x, so you are going to get a negative value. Okay, ingat test value kita substitute dekat dalam f prime x, bukan dekat dalam original equation. Substitute dalam f prime x. So negative 0.5 substitute into f prime x, you are going to get positive value. Boleh tekan calculator sendiri. Here we get negative, here we get positive. Okay, so what does it mean by our f prime x? So here, the line here, sini ialah positive, sini ialah negative. So the gradient here. So negative, this one here. So positive, this is the gradient. Negative, this is the gradient. Positive, this is the gradient. Okay, so what does it mean by the gradient here? This is the point. Let's say the point is here, the point is here, the point is here. So that means the point here is negative 1. So the pasangan ialah negative 1, pasangan dia ialah 0. So here we will have negative 1, 0, and this one also ialah pasangan dia 2, negative 27. 2, negative 27. So as you can see here, turun, naik. Okay, ataupun bentuk dia macam ni. That means your negative 1, 0 is minimum point. And also, 2, negative 27 is also a minimum point. Okay, so negative 1, 0 to negative 27 are minimum point. Okay, so what about this part here? Okay, 0. Okay, 0 pasangan dia ialah 5. So 0, 5 is, so as you can see from here, naik, turun. So this is a maximum point, is maximum point. Okay, so tak payah hafal dia naik turun ke naik turun, kamu tahu kalau bentuk dia macam ni, ini ialah minimum. Kalau macam ni, bentuk dia ialah maximum. Okay, so that's gonna be our answer. Okay, so let's try one more question here. We have example 4. Given a function of fx is equals to 9 over 5, x 5 over 3, minus 18 x 2 over 3, determine the nature of the points. Okay, what does it mean by the question said nature of the points? Basically, it's just extremum points kita lah, benda yang sama. Okay, extremum points kita. So now, we have 3 steps. So the first step is to find our first derivative. So f prime x is equals to 5 over 3 multiplied by 9 over 5. We are going to get 3x power minus 1. We will have 2 over 3 minus 12x negative 1 over 3. Okay, so now kalau we know that the second step is we have to equalskan f from x equals to 0. Okay, if you want to find your value of x, obviously kalau macam ni, dalam bentuk macam ni, kita kenalah factorizekan dulu. So how about we factorizekan siap-siap. So 3 dengan 12, we can factorize 3 x 2 over 3 and x negative 1 over 3. Yes, we can factorizekan. Ingat, factorizekan the lower value, the lower power. So we are going to factorize negative 1 over 3. So here x 2 over 3, x negative 1 over 3, negative 1 over 3 tambah berapa dapat 2 over 3? Tambah 1. Okay, power 1 lah kat sini. So here minus 4. Okay, so now better. Okay, this is better. So the function of your f prime x is 3x minus 4 over x 1 over 3. Okay, see that we have an undefined. Okay, function f prime x undefined. So kita tak nak tinggalkan yang itu. So now let's move on to the second step, which is we want to find the stationary point or critical point. So we will have f prime x is equals to 0. So we have 3x minus 4 over x 1 over 3 equals to 0. So ini naik atas akan dapat 0 lah. And then we will have 3x minus 4 equals to 0. Divide by 3 pun 0 juga. So here we will have x minus 4 equals to 0. X equals to 4. Okay. And don't forget that we have another one here. F prime x is undefined. Okay. Jangan lupa ada yang ni. Kalau tak, kamu tertinggal satu point. So x 1 over 3 is undefined. When f prime x is undefined when x 1 over 3 is equals to 0. So therefore we have x is equals to 0. So now we have two critical numbers. Okay, just find our value of y. So f4 sub into the original equation here. So equals to 9 over 5. Berapa? 4, 5 over 3 minus 18, 5, 4. 4, 2 over 3. Here we get the answer, negative 27.2. Okay, so the other value is 0. This one obviously akan dapat 0 lah. Okay, so we can conclude here first that for negative 27.2 and 0, 0 are critical points. Okay, tapi kita bukan nak cari critical points kita nak determine the nature of the points. Okay, we want to determine the nature of the points. So, kejap saya susun balik. Agak kamu confused. So, here is our second step. This should be our second step. So, saya bawa pergi sini dulu. So, this is our second step. Okay, so here is our second step. And then we are going to move into our third step, which is to use the table, the first derivative table. So here we are going to use the table. Kita lukis table kita. So we have two value. We have 4 and 0. So we have 0 and 4. So this one macam biasalah, the first thing is interval. And then test value, sign for your f prime x, and then the gradient of our f prime x. So the interval we have negative infinity, 0, 0, 4, 4 to infinity. So here have negative 1, 1, 5. Okay, so now to find the sign for your f prime x, just substitute the test value here into here, the function here. Okay, so this one should get you positive, negative, positive. Boleh try masuk sendiri ya. Ni masuk dekat dalam ni, you get positive. This one masuk dalam ni, you get negative. This one masuk dalam ni, you get positive. Okay, so by looking at the sign, we know that the gradient is like this. Positive, negative, positive. Okay, so therefore, our point here is 0. So the pasangan for 0 is 0. So 0 is basically our maximum or minimum point. Here, maximum point. 0, 0 is maximum point. And also, the next one here, the point here is, here the point is 4. 4 is negative 27.2 is minimum point. Okay, so that is how you use your first derivative test. Okay, by using first derivatives test table. So you can do this example 5 by yourself. So the answer here is negative 2, 5 maximum point. 1 over 2, 39 over 4 minimum point. Okay, alright. So next